let's first. So has science been right? Has science been right before? I'm just going to look at, I think last time we talked about tobacco, I think, and acid rain. You know about acid rain, and you know ozone depletion and climate change. So acid rain was, back in the 1850s, scientists discovered that rain was becoming acid. So they saw that their factories are putting smoke into the sky. The smoke is getting into the clouds, turning them acid, and this is falling. And from in the 60s and 70s, the scientists started to get very worried about this. And in fact, this was this was happening in Europe when I think mostly factories in the UK were putting smoke into the sky. And they thought, oh, we can just make taller chimneys. And if we make the chimney taller, everything will be okay. But everything was okay near the factory, but the smoke was going up and then going across the North Sea and falling on the forests in Sweden and Norway. And a similar thing was happening in North America between Canada and the United States, where of course, pollution doesn't care where the border is between two countries. It'll go and follow the wind. So there was an issue going both ways from Canadian factories. The pollution was going into the US, and US factories, the pollution was going into Canada. More from the US into Canada, but this was going both ways. So there was work between scientists from the Canada and scientists from the US working together to try and work out, is this a problem? And as we've kind of seen before, industry, mostly this was electricity generators who did not want this problem to happen. So there was some pushback against regulation for this problem. And I think there was more pushback from the US, where there was more industry. And the scientists in Canada, the government in Canada, was much more worried about protecting Canadian forests, of which there are more. US was more concerned about protecting US business. But there was regulation in 1990, the US Clean Air Act. And since the 1990s, acid rain has become less of a problem. I think there still is some acid rain, but it's much less of a problem than it was before. And of course, this happens as different countries have industries. This happens in different places. But this is basically, I think, a victory for science. Science has won over industry. Another very good example of science working is the ozone hole. So people started to worry about ozone is 3 oxygen atoms. So oxygen is usually 2 oxygen atoms, and ozone is when you get 3 atoms working together. And in the high atmosphere, this helps protect, it cuts out some radiation from space. So in the high atmosphere, ozone is quite helpful. Down here, ozone is pollution. So ozone is not good if it's in your room, but it is good if it's high in the atmosphere. And people started to work out that ozone, there were some chemicals that we were using, CFCs, that were being used in aerosol and spray cans and also in refrigerators. And these chemicals were going into the atmosphere and they were not going away. So they were staying in the atmosphere, building up in the atmosphere. And as they got to the high atmosphere, these chemicals were destroying ozone. So the scientists, Molina and Rowland, in the 1970s, they started saying, look, this is probably this may be a problem, that we're producing these chemicals, and maybe we should do something about it. And again, the industry said, no problem, don't worry, nothing to see here, please move on, keep buying your refrigerators, keep buying your spray cans. And then later there was they discovered that there was a big hole in the ozone layer over Antarctica. The scientists discovered from satellite data and from other data that they could measure, and this science was very solid. And within 2 years, very quickly, what's called the Montreal Protocol was signed, and they agreed to stop using and stop making CFCs. So the chemicals that were being used were stopped. So this is quite a good, quite a success. This is a good success for environmental campaigning, and also a good success for science beating industry. And so since the 2000s, there's been a recovery, and I think now we don't hear so much about the ozone hole. The ozone layer is kind of safe. Smoking. So smoking, we know from 1950, scientists have suspected that smoking is probably not good for you. The industry, since the 1950s, the industry has had a very well organized campaign against the science, first of all against the data, but also against the science and against the scientists. There was 1964 the US Surgeon General, who is responsible for the health of the American public, in 1964 gave a warning. There was regulation in the 60s and 70s on TV. And the problem, so since 1960, smoking rates have fallen, but this is the profits of Philip Morris, which is a tobacco company. So it seems like the tobacco industry is still there. It's still large, and it's still profitable. And this is the profit of one of the tobacco companies. Recently, you may have seen that tobacco vaping, so non-burnable tobacco products, have recently been pushed by the tobacco industry. And this is Philip Morris's profits. The black is smoking, the same as the color of your lungs if you smoke. And the blue is smoke-free, so e-cigarettes and vapors. And you'll notice that at first it looked like they were making profits. So the profits are still going up and profits from cigarettes are going down. But from a couple of years ago, profits from cigarettes have been going up again. So it seems good news for the tobacco industry. Everything is fine. Business as usual. So this is kind of science 2, industry 1, if we're keeping the score. So climate change then, again, we've got a similar story where the scientists discover something is wrong. The scientists get evidence. The evidence becomes indisputable. And industry objects and pushes back against the evidence. In this case, there was international action began in the 1990s, where we had the United Nations climate change. I'm not sure what the FCC is. The United Nations set up a group to fight climate change. In 1997, the Kyoto Protocol was a major international agreement to do something about climate change. And in 2015, there was an agreement to keep the warming below a certain temperature. Has the problem reduced? This is from the top of a mountain in Hawaii. This is the carbon emissions since 1960s. Can you see the agreement in 1992 on this chart? Can you see the Kyoto Accord? Can you see the Paris Agreement? To me, this looks like carbon dioxide is steadily going up. We can still, good news is we can still see seasons. We still have seasons. There's still life on Earth is still breathing, producing more carbon dioxide in the summer and a bit less in the winter. But it's very difficult to see an actual drop. Well, there is no drop. There is no drop in carbon emissions going into the atmosphere. And it's very difficult to see any change. It still looks to be increasing to me. But maybe you can see, this is another graph. This is, this is energy. This is world energy, most of which is producing carbon dioxide. And so maybe this is the amount of carbon dioxide that's been put into the atmosphere because the oil and the coal and the gas are being burnt. So what can you see? I'd like to talk to each other. What can you see? This looks like a, I think there's a dip here. I think there's a dip. Maybe there's a dip. I think there's a dip here. There's a dip here. There's maybe a dip here. There's a dip here. So please talk to each other. What can you see on this chart that's maybe stopping the rise? Please discuss. We can't see Kyoto. We can't see Paris. We can't see the starting of the IPCC. But we can see the oil shock. Hang on, sorry. We can see the oil shock. There's two oil shocks, the first and the second oil shock. We can see the Lehman shock, and we can see the COVID. So this was the first oil shock was more political, where there was political problems with the Middle East. But the Lehman shock was an economic crash, and the COVID was a pandemic. So these all have made a difference. These have made a difference to carbon emissions. I don't know whether. Well, sorry. Yes. So not necessarily a good thing. I don't think pandemics are a good thing. And I certainly don't think necessarily an oil shock is a good thing. Yes, we can talk more about that later. But so just looking at most of the carbon emissions, most of the carbon is going into the atmosphere from burning fossil fuels, and mostly energy results or has been resulting in fossil fuels, and mostly the economy is connected to energy. So when the economy is going well, it's using lots of energy. And if the economy slows down, then energy use also slows down. And there's a connection between politics and economics. I'm not sure which way the connection goes, how much politics does affect economics, but economics also affects politics. So sometimes politics is pushing economics in a certain direction, and then it pushes back. So just to look at these, what's happened with these. So in ozone and acid rain, I think in both of these cases, science won, industry didn't win. I think tobacco so far, industry is winning. Climate change, it looks like industry is still winning. It looks like science hasn't made a big difference yet to actual emissions. And if we look at, first of all, how much money is involved, in the case of ozone, I was going to say not very much, only billions of dollars. $1 billion is a lot, billions of dollars is a lot, but compared to tobacco is worth tens of billions. Acid rain, the utilities that were producing acid rain are worth hundreds of billions, and the fossil fuel industry is worth trillions. So there's a big difference in the amount of money involved. Another big difference is how much. So the tobacco industry, their entire business is tobacco. So if tobacco stops, then the tobacco industry stops. Basically, there's no option. In the case of acid rain, there are options. They can find other ways. They can clean the smoke, and there are other options. In the case of CFCs, there are other alternatives to CFCs. In the case of fossil fuels, there are alternatives to fossil fuels, but they are not made by the fossil fuel companies, and they represent a very different business. So just as in terms of the industry threat, so acid rain, this is going to cost us money. Ozone, this is going to cost us money. And in the case of smoking, this will destroy our business. And in the case of climate, this will transform the global economy. And if the global economy changes, then right now the fossil fuel industry is very rich and very powerful, and any change to the global economy will change their business and their hopes. What's interesting then? What's most interesting is ozone was a very, very fast reaction from very strong scientific evidence. Within 2 years, there was an international agreement. And what's interesting, it's not so much why did the other problems take so long to solve. One interesting question is, why was ozone so fast? And I think if we look at the case of ozone, one thing was that ozone, the CFCs were patented. There was a patent, so the CFCs were owned by a US company. And the patents only have a limited time. It's quite an old chemical, and their patent was running out. And if the patent runs out, anybody can make CFCs in any company. So the profits were starting to fall on CFCs. The strict trade restrictions that were suggested by the Montreal Protocol, this in fact will help businesses in the US. So the US in fact benefits where there are trade restrictions. This often helps the US to sell and to stop other companies or other countries from selling products. So the US can try to stop, for example, can stop Malaysia and Japan from trading. But Malaysia can't stop the US from trading. So there's an imbalance in the power. There was a timeline for transition. So these treaties were not an immediate ban, but the ban would take a few years and give the companies time to change. And of course, in the case of ozone, CFCs are a chemical. This is a chemical company, and they can sell alternative products with a new patent that will last another 10 years. So this is kind of good. This was good for business for the chemical industry. In addition, the public was very unhappy. These were very visible products that the public was unhappy with, and they could also get goodwill with the public by going green and going environmental. So this was. So I think the reason why ozone was quickly adopted is because this was good business. This was a good deal for the large chemical industries. I'm just going to introduce three people who you probably have never heard of. This is Fred Singer, Fred Zeitz, and William Nierenberg. And these people were involved with all three the tobacco industry's attempts to stop the science against tobacco. In the case of acid rain, there was also a pushback from industry to try and stop any regulation on acid rain and keep the companies allowed to produce and allowed to pollute. And also in the case of ozone, there was some pushback against ozone regulation. And in the case of climate, all three people have been involved trying to fight against climate regulation and trying to fight against the science of climate change. And these people were all, I think, involved in the Cold War. and I think in nuclear physics. And nuclear physics was very important in the 1940s for the Manhattan Project, which was one of the most expensive, probably one of the most expensive projects that humans have been involved in, was the project to make a bomb. It was made, originally the idea was that the worry was that the Germans would get a nuclear bomb, and so the Americans and the British wanted to make a nuclear bomb before the Germans could. As it happened, very unfortunately for Hiroshima and Nagasaki, the war was won against Germany, but the development of the bomb continued. And it continued the Manhattan Project was a massive project that was very secretive. The Americans and the British did not want anyone to know what they were doing. So a lot of the people working on the project didn't know what they were working on. So some of the developments were done very secretly. There's also there's a conflict between the war and environmentalism. Generally, people who support the environment and don't want to damage the environment also don't want war. So there's a strong connection, I think, between anti-war and anti-environment and anti-nuclear weapons. And I think there is also a strong connection between nuclear weapons and nuclear power. So this puts nuclear physicists on one side and environmentalists on the other. So often we see in politics, there are tribes, and the tribes will fight against each other. So there seems to be these people were all involved in the Cold War, were involved in nuclear physics, and also that involves being against communism because of the threat of the Soviet Union and the threat of Russia. And if you're against communism, then you must be for the free market. So the free market is the opposite of communism. So there are people who are very determined to support the free market and to fight against environmentalism. So the end of the Cold War. So when the Cold War finishes, it seems to me at the end of the Cold War, the problem of climate change seems to me to have been the biggest problem since before the end of the Cold War. Certainly since the 1980s, climate change seems to be the biggest threat facing the world. But I think for these people, the biggest threat is environmentalists. So people who are trying to fight against the free market, which I'll come back to that later. So there are three, but I think there are three reasons if you want to try and deny that the climate science is real. One of them simply is money. If you have an oil company, if you have money invested in an oil company, climate science is bad for business. I think there's also a political angle. If you believe in free market and freedom, then regulating against climate change is against freedom and is against the free market. And I think there may also be religious, which I'm not going to go into religion. One thing is that there's only, so the idea of parts per million, when we're talking about carbon dioxide, some people will say, carbon dioxide is only a few parts per million. What difference can that possibly make? If it's 10 parts per million or 100 parts per million. But I think if we look at small things can make a big difference. And if we look at people, a few parts per million in the population can make a very big difference. And often big changes in the world start with one or two people. And those one or two people, and in this case, well-organized anti-science can make a difference, especially in the US political system. This is very complicated. And this is the citizens. This is political organisations in the US, and the citizens are over here, and the administration is over here, and over on the other side is corporations and businesses, and there are lots of small organisations between the corporations and the politicians, and there's a lot of money is flowing from the corporations. Not directly to the politicians, but the money is flowing to one organisation, then another organisation, and then from that organisation to the politicians. So we have a complicated ecosystem that allows money to go into politics. And often in the US there are Democrats and Republicans. The money is going to both Democrats and to Republicans. So the money doesn't mind if it's a Democrat or a Republican. The money just cares, have we paid for the politicians? And once politicians are paid for, they know where the money is coming from. And money does influence people's decisions and what they believe. So I'm just going to try and go from two politicians. I don't like either of these. To be honest, I'm not a big fan I'm certainly not a big fan of Donald Trump, and I was never a big fan of Margaret Thatcher. However, this is something that she said in 1988. This is a speech from Margaret Thatcher to the Royal Society is a British scientific organisation, which goes back hundreds of years and has been involved with Newton and Faraday and various Darwin and Kelvin and various scientists have been involved with the Royal Society. Interestingly, Margaret Thatcher was a chemist. She was a scientist. She has a PhD in chemistry. So unusually among politicians, she understands science. Most politicians don't understand science. They understand rhetoric and how to speak and how to persuade people. So she very quickly, she understood the climate science and knew what was happening. And she said, so for generations, we've assumed that the efforts of mankind would leave the fundamental equilibrium of the world's systems and atmosphere stable. But it is possible that with all these enormous changes, population, agriculture, fossil fuels, concentrated into such a short period of time, we have unwittingly begun a massive experiment with the system of this planet. So this is 1988, and a year later she spoke to the United Nations, saying it is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. So this is back in 1989, when and this is not among scientists. This is not revolutionary among scientists. This is more or less what the scientists were saying at the time. This was not widely understood in the population and not widely understood among politicians. I think this was widely understood in the oil industry, because also the oil industry has chemists and they have scientists and they do understand the science. But so the problem of global climate change is one that affects us all. Action will only be effective if it's taken at the international level. And she said also it's no good squabbling over who is responsible or who should pay. So these are, as I said, I'm not a big fan of Margaret Thatcher, but I think here she's absolutely right. And what she said then, this is all still true. And unfortunately, it's not always been followed. Here are some US politicians a few years later. They're talking about climate change is trendy science that's propped up by liberal left politics rather than good science. Climate change is the greatest hoax ever perpetrated on the American people. This is a Republican senator, 2003. And in fact, by Thatcher, she stopped being prime minister in 1989, I think. Not long after speaking to the United Nations, she lost her. She stopped being prime minister. I think there is no connection between her stopping being prime minister and her talking about climate change. I think I don't know any evidence, but she did about 10. This is maybe 10 years. This is 2003, and she's also following the new dogma about climate change has swept through the left of centre governing classes. And she also says that Kyoto was anti-growth, anti-capitalist, anti-American project, which no American leader alert to his country's national interests could have supported. So interestingly, she looks, her opinions have changed. She's gone a bit further to the right. So maybe what she was saying in the 80s was a short time. And this is what she really thought. This is Dick Cheney, the vice president, speaking in 2007, where there does not appear to be a consensus. Where it begins to break down is the extent to which that's a part of the normal cycle versus the extent to which it's caused by man, greenhouse gases, etc. This is so what Margaret Thatcher was saying 20 years earlier is what the scientists were saying 20 years earlier and what the scientists were still saying in 2007. This is just bad science. He's wrong. And he's the vice president. So again, this is Trump repeating the idea. The concept of global warming was created by and for the Chinese in order to make US manufacturing non-competitive. So wrong and racist. And then he said that the con artists changed the name from global warming to climate change when global warming was no longer working and credibility was lost. You may remember Margaret Thatcher talked about climate change 25 years earlier. So the scientists, this is also wrong. And I think there's some connectivity. There's something. It depends on how much. It also depends on how much it's going to cost our companies. So Trump seems to be saying that the size of the problem depends on how much our business will lose. So if we're going to lose a lot of money, it's not a big problem. If it's going to be cheap, then we can say it's a big problem and fix it, which is interesting. And then he says again, I'm still open-minded. Nobody really knows. Again, yes, they do know. So in fact, being open-minded is a political position. If you say in 2016, I don't really know what's happening with climate change, that's a strong political position that you're taking against science. This is interestingly, yes. So again, when Trump became president, the Environmental Protection Agency was set up, I think, by Nixon in the 1970s and to protect the environment. And when Trump became president, he put the head of the Environmental Protection Agency, he put somebody who says that scientists continue to disagree about the degree and extent of global warming and its connection to the actions of mankind, which is not really true. It's a very, if you kind of squint, maybe he's not lying. Maybe he's not lying, but it's certainly a very twisted view of what the actual scientists were actually saying. And he's in charge of protecting the environment. So there's more. There are more and longer. This is This is Trump at one of his rallies, and it's very. I don't know how. I imagine whoever has to translate what Trump says into Japanese, it must be very difficult, because the way he speaks is he doesn't really have sentences. He doesn't really have a flow. He kind of goes in this direction and then jumps over here and then jumps over here. So this is talking about, first of all, how coal is great. You can't blow up. He's talking about blowing up. He's talking about blowing up pipelines. He's talking about blowing up windmills. And then he starts talking about the birds and how windmills kill birds. And then what happens if the wind stops blowing? The windmills stop. So one thing very clear from this: Trump does not like windmills. I think we can see. And this is Trump talking to the United Nations, 2025. This is last year. This climate change, it's the greatest con job ever perpetrated on the world, in my opinion. All of these predictions made by the United Nations and many others, often for bad reasons, were wrong. All the predictions were wrong. All the they were made by stupid people that have cost their countries fortunes and given those same countries no chance for success. If you don't get away from this green scam, your country is going to fail. So watch out. Just back to reality. So there is a consensus among scientists. The scientists, as we've talked about before, climate change is happening because of us. It's very difficult to find a scientist who will disagree with this. They may, whether it's 2 degrees or 3 degrees, some of the details, of course, scientists are looking at the details because that's their job. The job of scientists is to find out what we don't know and find more knowledge. Climate change, in fact, this is from a Republican strategist who I think was working for one of the Bushes, who suggested that they should say climate change instead of global warming, because climate change sounds less alarming. So it's not the scientists changing the word. It's not the scientists changing the wording. One of the people changing the wording was an advisor to George Bush, who was trying to help him play down and stop talking about climate change. Good science is being ignored by politics. I think good science is being ignored by politics, but usually it's the politicians on the right, and I think there's a connection with money that they are being paid by industries who don't like the science. And I think if it costs more, so there's a problem as Trump, some things that Trump says are very wise. And I think his idea, if it costs more to fix a problem, then people think the problem is less serious. So if a problem is too expensive to fix, we can very easily stop seeing a problem if it seems too expensive. And if something is quite easy to fix, then we very quickly say, well, let's fix this problem. It's going to be easy. So I think this is a kind of human problem. So let's assume that climate change is a problem, and let's assume that we want to try and fix it. So if we do want to try and fix it, how do we reduce, it's carbon dioxide. It's very simple. Carbon dioxide is going to the atmosphere, and this is causing problems. So how do we reduce carbon dioxide? Now, what I'd like you to do is have a think. Could you talk to each other and come up with where is the carbon coming from? What is the cause of this problem? And please come up with them. Talk to each other. I suggest you work together. I suggest one of you write down your ideas and talk to each other and try and come up with a list together. There's some methane, CH4. When things melt, some gas is going to come out of the ground. So there's a danger as ice melts. There are some things under the ice and dissolved in the ice that are going to release thousands or millions of years of carbon dioxide. So yeah, just one thing with this is you may know about this. This is called Pareto analysis, which you may have heard of. I heard about this in Japanese QC circles, but Pareto was, I think he was a tax collector. He was an Italian tax collector, and he realized that something like 20% of the people owned 80% of the money. So if he was collecting tax, then if he just concentrated on the richest people and collected tax from the richest people, it would be easier and he could get more tax. This is a wonderful idea. And I wish he was alive today. But this also applies to many things. So if you're looking at some problem, usually the problem has various causes. And among all the causes, there are often one or two which cause most of the effect. So if you're trying to solve a problem, if you can work out... So for example, none of you said turning lights off, leaving the lights on. If I switch these lights on or off, it's not going to make a big difference to global warming. If I have a coal-powered power station, if I have a coal-fired power station and I switch off the power station, that will make a big difference. So if you're a politician and you have a switch for your country's energy system, then those switches will make a big difference. These switches will not make a big difference. So just one thing we can look at, looking at the system. These are kind of system level issues that affect climate change. One of them is the population. One of them is economic activity. As we saw before, if there's more economic activity, there is more climate change, there's more carbon dioxide is emitted. But the other thing also is energy. I've put energy inefficiency, because if energy is used more efficiently, then there will be less emissions. And also carbon density. So how much carbon is going into the energy will make a difference. So and these are all multipliers. So if the population doubles and these other things stay the same, then carbon emissions will double. And if energy efficiency, if we get 50%, if we use half the amount of energy, then this will go down by half. So these all multiply to affect our problems. I'm just going to look at just very briefly looking at population. Population, I think. These are three big things that affect population growth. One of them is education for women. If women are allowed to go to school, and now in some countries women are not allowed to go to school, if they're allowed to go to school and to university, and if they're allowed to have a job and a career, this makes a difference to population growth. If the only thing that women can do is have babies, then you have more babies. So that's one very simple. And if you look at somewhere like China has very good education, and the Chinese population has leveled off and decreased. Another thing is economic growth. If the economy gets better, people tend to have fewer children. So going back to the problem, this is a balance, because economic growth also will cause more carbon emissions. And another thing is urbanization. So as people move from the countryside into cities, there tends to be a population. The population the growth tends to get less. So it looks like population has been increasing. These are various predictions for the population, where the population is going to go, and it will continue to increase, but it will probably stabilise sometime before the end of this century. It will stabilise around 10 billion. So the population is not going to get much bigger. And if you the solution, we could, if we remove the human population, then we will solve. The planet will be fine. I think the planet will be okay if we can remove the humans. But the point is we want a planet that is nice to live in. So if there are no people, then there is no point in having a planet. And also there are some very nasty things that we can do to population, which I don't think we want to do. And as I said, I think if we wait, the population will stabilise, and it will not continue to grow forever. This is a politician who I do like, who unfortunately only served for one term, and was very unlucky, I think. And something he said, this is the White House, and those are solar panels on the roof of the White House in the 1970s. After Carter, Reagan became president, and he took down the solar panels. I think Reagan was getting lots of money from the oil industry, who I don't think wanted solar panels. They wanted them to buy oil and fossil fuels. And I think possibly this building has now been knocked down. So that's yeah. And one thing he said, again, there are some things that people have said a long time ago that are still true. So conservation is the quickest, cheapest, most practical source of energy. So if you want to have more energy, then try using less energy. Then you will have more. So if you can make things more efficient, then you will lose more. I asked you to come up with. I think you came up with all these things. So here are 5 big. These are big carbon emitters that all begin with C. So cars. So cold. So one of the big reasons for global warming is because we've been burning stuff to keep warm, which is, I don't know if that's ironic, but about 25% of energy goes into heating and or cooling. And I'll just come to that in a moment. Cars are something like 15 to 18% of energy goes into cars, making cars and driving cars. Transport in general is a big use of carbon dioxide. Cows, as you mentioned, agriculture is one of the carbon emitters. Agriculture can also be a carbon sink. So often the things that we grow are taking carbon from the atmosphere. So agriculture can reduce carbon emissions. Cows do not. And together with the next one, together with chainsaws is deforestation. And what tends to happen with cows is forests are cut and then replaced either by cows or by crops that are grown to feed cows. Cows are very inefficient. It's a very inefficient way of getting food, because cows actually eat soybeans. A lot of soybeans are used for feeding cows, and cows are warm-blooded. So most of the soybeans that cows eat, they use to keep themselves warm. And then if you eat beef, that's something like 20 times, that uses something like 20 times the amount. If you just eat tofu, eat soybeans, you can get 20 times more food, or 20 times less. So cows are surprisingly big. And the other thing that no one, you mentioned factories, but concrete is something like 7 or 8% of carbon emissions come from making concrete. And again, some of the concrete is used for making bridges for the cars to drive over. So there's, like with all problems, there are a few big issues, and if we want to tackle climate change, I think we need to think about, these are things that we do need to think about. Everything else is about 25%. And everything else includes, for example, steel. Steel is another big one. You mentioned flight, you mentioned aeroplanes, that does make a difference. Shipping, also ships sailing around the world is also significant. But they're all kind of 1 or 2%. Heating. So global, I think this may be a bit 2040. It may not be as early as 2040. But what's happening now is heating. The world is getting warmer, so we need less heating, and also we're becoming more efficient. So heating is becoming more efficient. I hope buildings are becoming more efficient. So we're using less energy for heating. But at the same time, cooling demand, we need more energy for cooling because the world's getting warmer. Also because we have large populations in warm countries moving into cities and becoming richer and buying air conditioners. So as you mentioned, air conditioning is part of this. So let's just talk about generation. Let's talk about generation. So here are some questions for you. Are these true or false? Wind turbines kill birds. Solar panels give you cancer. Wind turbines never pay back their carbon cost. Solar power can produce 100% of our energy needs, and it takes more energy to make solar panels than they produce. Please discuss. What do you think? True or false? True or false? It's really good. So, true or false? Wind turbines kill birds. True? False? I guess true or false? True or false? No sitting on the fence. True? False? Solar panels give you cancer. True? False? Wind turbines never pay back their carbon cost. True? False? Solar power can produce 100% of our energy needs. True? False? It takes more energy to make solar panels than they produce. True? False? Yeah. So the first one, wind turbines kill birds. This is true. However, they're not the only thing that kills birds, and they're certainly not if you really are worried about those poor birds, then cats kill billions of birds. So if you want to stop, and not windmills, but windows, lots of birds fly into windows. And especially when we have these tall buildings with glass all around, which is really stupid. It's very stupid from an energy point of view, because some glass it gets too hot in the summer and gets too cold in the winter, and dead birds. And vehicles, lots of vehicles kill birds. Power lines kill birds. Pesticides kill birds. Wind turbines do kill birds, but not that many. And the question is, how do you, if you're going to generate electricity, how should you generate electricity? Obviously, but killing birds is one question. Could you? There are different ways to make electricity. Wind is one. Solar is one. What else? Please discuss. What other ways are there? There are various. There are many. And I think the oldest. These are all 19th century power generation technology. Hydro. You mentioned water. So hydroelectric power is quite old. Probably the oldest electricity generation, I think, was from water. Before water was used for mills. So for a long time, water has been used to turn power. Coal is also quite old, and wind power is also quite old. Windmills have been used for grain and milling for a long time. So these have all once they made a generator. This has been added to water wheels and windmills, and of course steam engines. We have steam power. In the 20th century, geothermal in Italy from the early 1900s, they've used power from. I always think Japan should have more geothermal engines. There's hot springs everywhere, and there's volcanoes and there's earthquakes, and I don't understand why Japan doesn't have a big geothermal. So oil later was used for making electricity. Gas more recently. Nuclear is from the 1950s. The first nuclear plant was in the USSR and the Soviet Union. And around the same time, the silicon cell was invented to make solar electricity. So that's the most recent one is probably solar electricity. There's a few others that are kind of these are new. I don't know whether these really are new, but there's some biomass, which is using burning trees or pellets to make power. Tidal energy. The tide goes up and down every day, and very reliably. And if that can be turned into energy, that seems like a sensible thing. And also wave energy, which I'll talk about maybe next week. So, which one of these different energy sources? Next question. Which of them is zero carbon? Please discuss which of these energy sources do you think is zero carbon? Nothing. Yeah, I'm afraid you're right. None of them. None of them is zero carbon. And the reason is that carbon is used or emitted. So if you want to have a windmill, or if you want to have hydroelectric, you need to build the windmill. You need to make the dam out of concrete, and concrete is going to put carbon dioxide into the atmosphere. Or if you're transporting, if you get solar panels, they will probably arrive in a truck with a big smoky diesel engine. And when they're being maintained, so when they're fixing things, that may also use carbon. And then when they finished, what happens to the parts, what happens to the products at the end of their life, that may also emit some carbon or use some carbon. So you have something like if you're looking at the whole life cycle, and we need to look at the life cycle of a project. Once your solar panels are on your roof, they're not producing any carbon while they're running. Basically, they're not producing any carbon. There probably is a power conditioner, and the power conditioner may use electricity to start. So even solar panels, while they're running, there's often some electricity, some power that they're using. And that once they're running, that's going to be they'll use their own power. So you basically have the construction where this is looking more at the amount of energy that's being used, for example, in making a dam or making a solar panels or a windmill. And there's some energy used in the construction. So when it starts running, you're already at minus carbon, minus energy. And then as it runs, there's some energy is used to keep things running, but mostly you're generating. And then when it's finished, it's decommissioned. And we can look at this for different kinds of power generation. And in all cases, we're putting in some energy and taking out some energy. And if we're putting in, hopefully we're getting out more energy than we're putting in. If we're putting in more energy than we're getting out, this is not going to help us. So what's the best way to make energy? So we can look at two things, of course, which is the cheapest. This is always going to be important. But also, which is the lowest carbon? Because low carbon is also important. It would be very nice if the cheapest option was also the lowest carbon option. That would be an ideal world, but it's not always. And this question may be different. So if you're an electricity company, or if you're a government, or if you're a business, or if you're a homeowner, then you may choose different kinds of power. If you're an electricity company, and you already have a coal power station, then probably you want to keep using your coal power station, keep buying coal. If you're the government, you may be maybe a difficult situation as a government. You may want to have security. So you may be, if you're using coal or if you're using gas, where is the gas coming from? And what happens if the gas stops? And should we try to find a different option that's safer? If you're a business, you may have a different view. If you're a homeowner, I think if you're a homeowner, it's kind of easy. But I'll come to that. So there are different. There are kind of three big factors. One of them is the cost. One of them is carbon emissions. And I've just looked at energy. So energy return on investment. So for the different power sources, how much energy do we get out compared to the energy that we put in? And different. So these are the. So for carbon dioxide, solar, actually hydroelectric is probably the lowest carbon. Probably the lowest carbon. Once you build a hydroelectric power plant, it will last a very long time. So the initial cost is quite high when you're using the cement, but once the cement is poured, once the dam is built, you have quite low carbon power. Nuclear also is quite low carbon. You may not like nuclear. There are other issues with nuclear, but in terms of carbon, nuclear is good. Possibly better than wind, and probably better than solar. So for carbon, right now, solar is compared to coal, solar is very low carbon. So all of these are, we can argue that maybe hydro is better than solar or nuclear is better than solar. But all of them are much better than coal. So if we change from coal, as far as carbon is concerned, any of these is much, much better than coal. We can argue if nuclear is good or bad, but coal is definitely bad, whatever we're doing. And we can looking at how much energy goes in, how much energy comes out. Again in this solar, this has changed a bit from 2010 to 2022. Solar has got a lot better. The manufacturing of solar has improved a lot, and nuclear has possibly got worse. And there's a very confusing. So these are all importantly these are not exact numbers. It depends where your solar panels are. It depends where they are made. So there are lots of factors behind this. So the question, which is better, rice or bread? Please, quick. So this is it. This is the wrong question. We want both. It's not like you can only have bread and no rice, or you can only have rice and no bread. We don't say this. So the question, which is better, bread or rice, is not really a question. We want both. And it's the same question. So wind cannot produce 100% of our energy, therefore it's no good. This is nonsense. If wind can produce half of our energy, that's great. and we have other sources of energy. So the idea that sometimes there's no wind or sometimes there's no sun, that's true, but that does not mean that we should not use any wind or we should not use any sun. So it's important to have some kind of renewable mix. So just a quick comparison with, I think we have a bit of time. Which country, so Japan does burn some coal. Which country uses less coal than Japan? The United Kingdom, France, Spain, Egypt, or Iran? Please discuss. The answer is all of these countries you have less than 1% coal. The UK has stopped burning coal. France has a lot of nuclear. Spain has a lot of solar, I think, and lots of wind. Egypt, I think, burns gas. I think has gas. And Iran, I don't know what Iran burns, but not coal. Not coal. This is Japan's. This is Japan's electricity production. This is the mix of Japan's electricity production. The blue at the bottom is hydro, and then you've got some coal coming in, then some petrol coming in later. The yellow one is nuclear. The brown one is coal. The light brown is natural gas. This one is This one is natural gas. And this is renewables, which is coming, or non-hydroelectric renewables, which is becoming bigger and bigger. And also, so we can also see this, the oil shot we can see here, and we can see Fukushima here, where nuclear drops off quite quickly after Fukushima and has not recovered, which means Japan is buying more gas, which I think is not good. Personally, I don't like nuclear, but gas is worse. I think, in my opinion. Which would you use in a house? Would you live under a nuclear power station? Probably no. Would you live under a thermal power station? No. Would you live underneath a hydroelectric power station? No. It may be very romantic to live under a windmill, but it may also be quite noisy. Probably for your house, solar panels are the obvious thing to choose, and the sunshine is bright. So which of these, Japan does have significant solar power. Which of these countries has more solar power, higher percentage of solar power? Please discuss. What do you think? Have a guess. All of them. All of these countries have more solar power than Japan. Pakistan, they noticed that their electricity usage was going down, and they found that people were importing solar panels with no support from the government, and they were importing their own solar panels, putting them on their roof, and using less electricity from the grid. So in the case of Pakistan, this happened not because the government was getting people to use solar panels. It happened because they were cheap and reliable. Pakistan doesn't have a very reliable grid. If you have your own solar panels, you have your own power and your own control. This is a list of the. This is the highest. So Luxembourg has 30%. I think that's the highest. These are countries. Japan is a little bit above. It's a little bit below the Dominican Republic and a little bit above India. And the UK is UK and South Korea are below Japan. So don't worry. So solar is good. Solar has some very good advantages. There's no fuel, there's no pollution, there's no noise. They're low maintenance. Once you set the panels, they just produce electricity for 25 years. Another important thing with solar power is modular. So you can have, if you have this much space, you can add this many panels. And if you have twice as much space, you can very easily make twice as much Nuclear power, you need to build a nuclear power station, which tends to be quite big. The disadvantages are high cost. That's actually not so. Actually, the cost now is not so high, and large area. The area is not actually that large, and if you have roofs, for example, there are areas where you can add solar panels. So the area is not so. The location is important for solar panels. And the season, so obviously summer and winter, there's different, and weather. So if it's snowing, if your panels are covered with snow, they don't produce much electricity. And so storage is an issue for solar panels. But the economics are that the cost of solar panels is falling all the time. And the cost of competition is getting more. So it's becoming, finding coal and finding oil is becoming more expensive because the cheap, easy places have all been used. And you now need to dig deeper or search further or go into different places. And battery prices are also falling. So this is one what's called the primary energy fallacy. So people sometimes say, well, Japan uses 700 billion kilowatts of coal every year, so we need 700 billion kilowatts of solar power. But in fact, most of the coal is lost to heat in the power stations. And then as it's transmitted around the country, it's lost. My solar panels on my roof, all of the electricity, or over 90% goes into my house. So you don't need to replace the same amount of coal if you transfer to other sources. And there's a difference if you have a mega solar somewhere on a mountain producing electricity, or solar panels on your roof where you're using it. There's a difference in the value of the electricity where you're using it. Let me just, 2 more minutes, and I'll get to a good stopping point. So, which country has more wind power than Japan? Any idea? Yes. All of these countries have more wind power. This is the total amount of wind, and Japan is on the list. It's not at the bottom of the list. It's not at the top of the list either. This is a wind map. You can get a wind atlas which shows you how strong the wind is in various places. And this is the wind. This is Nagano Prefecture, and there's a lot of wind in Nagano Prefecture. There's also a map of how many wind power stations there are in Japan. And this is Nagano Prefecture's wind power stations. There are none. Why? Here's my question for you to think about over the next couple of weeks. Why